Good evening, everyone. My name is Kumar, part-time research scholar under the guidelines of Dr. M. Sayyid Ali sir, Assistant Professor, Department of Mathematics at Tiruvallur University. Today, I have presented for the paper title Global Stability Analysis of the Fractional Order Memoristive Fuzzy BAM Neural Networks. Yes, sir. Arcot Triple College, sir. Neural networks with time variation delays and leakage time. And then the plan of the presentation and then abstract. In this paper, we discuss about the global stability analysis of the fractional order memoristive fuzzy BAM neural networks with time variation delays and leakage time. By using the theory of the fractional order calculus, the fractional Barberton lemma, and the properties of a fuzzy logic operator, sufficient condition ensure the uniform stability of the fractional order fuzzy BAM neural networks and assuring the global asymptotes of a stability of the equilibrium points of the system is derived. Example is given to the solve the effectives of the obtaining results. The keywords are there: fractional order and then fractional fuzzy BAM neural networks, and then global stability, time variation delays and leakage terms. And then next introduction. What is the fractional order calculus? The fractional order calculus is an area of the mathematics that deals with the extension of a usually calculus data for the last 17th country, and it is the register regression of the derivation and the integration of the arbitrary order integral orders. As a branches of the mathematical analysis and going to the topics, the fraction calculus deals with the derivative and the integration of the arbitrary non-integral. And then study of the dynamical analysis of the fractional order differential system as a sir. Sir, okay, sir. There are also dynamical analysis. They use it for the integration. And then, what is the fractional BAM neural network? The BAM neural network, it is the two layers are there. There are the single layer, the auto associative controller to the two layers of pattern. And then the BAM neural networks, there are the two layers, X layer and then Y layer. Then investigating the global asymptotes uniform stability is there are the two layers are equal. Then the stability analysis of the fractional order fuzzy BAM and then derivatives. And then next the memoristive. The memoristive neural networks listen to memoristic emulation Symposium as the highest effective capability of the associative memory. There are the two layers are equal. And then naturally the researchers mix the memoristor of the BAM to make it the neural networks named memoristor bidirectional associative memory neural networks that are investigated within the fact of the dynamical behavior. And then time variation delays and leakage term. But the time delays in the leakage term has also created impact on the dynamical behavior of the neural network. The stability analysis of the neural network with the time delays in the leakage also preliminary signification in the research of the neural network. And then last, it is also lower and upper bounded of the interval, the time variation delays and the available. The next, the problem description and the preliminaries. In this paper, we collected for the following fractional order fuzzy BAM neural network with the variation delays and the leakage term. There are the two systems are there, and then first one d beta d theta xi into t x layers, and then next one d alpha t into y of j into t is the second layer, and then at which the x equal to x1 and so on x of n, y equal to y1 and so on y of n, and then two layer in the BAM neural network model. And then first one you can use it for the Riemann-Leibniz fractional derivative of d beta t xi into t and d alpha t yi into g yj into t, beta alpha representative xi XIT, YJT. Their activation to the ith neuron and then jth neuron. We reset presentation for the issue. There are also the networks external input. There are also AJI and BJI represented the weighted coefficient of the neurons. The next we can use it for the elementary fuzzy feedback and then minimum template alpha JI, beta JI and then TJI, HJI. It is a fuzzy feedback minimum template, fuzzy feedback maximum template, fuzzy fed forward minimum template and then fuzzy forward maximum template X layer. There are also the same result of X layer and then Y layer. Then Y layer there are also Bij, Qij, Kij and then Rij. There are also same format to the fuzzy feedback minimum template, fuzzy feedback maximum template and then last using for the fuzzy and fuzzy OR gate. Then mu of Ji and then V of J, Ij and denoted extension input ith neurons and then X layer, extension input of the jth neuron and then Y layers. And then the additional impulsive movements Tk and then K is equal to 1, 2 and so on satisfied. Then del of Xit equal to Xi Tk plus minus Xi into Tk minus. There are also minus Xi Tk. Okay, sir. And then next we can use the memory star basic system number 3.2 where Wji equal to dVji divided by and then d of x ji and then hij is equal to j. There are the memory star basics and then the memory star system of it be changed for the neurons aij and then bij and also the equalator to the ti time variation delays. And then next where aij the minimum aij and then aij maximum 1 and then maximum 1 and then bij minimum and then same to the y layers I equal to 1 on j is equal to 1 2. There are the system number, there are memory stive fuzzy band neural network. There are the values of beta d power beta t into xit belongs to dij xit minus in alpha gamma and then summations of m j is equal to 1 the covariance of AJI. It should be changed for the next system of equalator. There the extension function aij belongs to co and then AJI xi into t bij belongs to co bij yj. It should be changed for the memories to fuzzy band neural network of the systems. The next definition 1 the fractional integral order of beta you can use it for this definition. And then definition 2 the using for the Riemann derivatives of the fractional order beta. And then next the definitions of 3 and then h of t w into t c power n into t naught b t naught comma b and then n minus 1 greater than or equal to beta and then greater than or equal to zeta power plus. And then there are the 3 conditions of the definitions of used any one. And then suppose the 2 statement of the system number 1 there is used for the AND layer and then OR layer. Then next you can use it for the bar button lemma. There are also use it the sigma system of the gamma divided by 2. And then next there are the same fractional bar button lemma. And then next the assumption 1 and then assumption 2 they are then used for the theorems. And then next under the assumption of 1 and then assumption 2 the system of global asymptotes the stability if for the sum contact equal to 0 psi 1 of less than equal to e. Sir. Oh, sir. Sorry, okay, sir. There are the results of psi 1 and then psi 2 and then next and then okay, sir. And then memory star There we consider the following Lebanon function and then collected for the Vt equal to, and then the time variation, the time derivative Vt along the system of 3.12 with the application of the definitions 2 and then definitions of 3. We can apply it for the definition 2 and then the lemma 3. We discuss about the values, and then it should be changed for the summation n ei. All the elements are the summations of m j is equal to 1 d bij and then pij plus q modulus of qij, and then next the y layers of there also the theta, and then last one the system number 3.14 Vt in the integrations of tk minus 1 and then epsilon divided by sigma 1 minus beta summations of n xi t minus s and so on. And then next there are also x layer and then y layer. We consider the v of tk plus greater than or equal to and then v tk minus 1 t power minus. Let vt equal to e power n I equal to 1 xi t minus sigma. There are also the equalated for the vt and then minus integral integral tk power t vs into ds plus t. Thus this we can get the following of the basic assumption observation for the limitation. And the next theorem number 2, the same theorem number 1 is the minimum was used, and then theorem number 2 the maximum proof it. There are the system number 3.16 and then there are also phi I xi equal to summations of m j is equal to 1. They are also used Riemann-Leibniz fractional order derivative of the constant xi star and then yj star, and then can be write as the system of 3.17 and then 3.18. There also now we saw that the theta is the mapping of the r power n plus 1 involved with the neurons z equal to maximum summations of n I equal to 1 xi summations of m j is equal to 1 y of j. Since for all the two different points there are the one is z equal to x1 and so on x of n, y1 and so on y of n, the transportation of t, and then another stability elements is equal to the z bar and then x1 bar and so on x power n into y1 and so on y power n into t. There also the system is the maximum equal to the values. For beta comma alpha belongs to 0 comma 1, the limitation t plus infinity theta t power minus beta they equal to 0, and the limitation t is equal to t power minus alpha equal to 0. Therefore there exists a small content of epsilon equal to 0 and equal to the t power minus beta. It can be used for the bar button lemma. There also theta z equal to theta z bar less than or equal to m maximum of values, and then yj minus yj bar xi minus xi bar, the last is z minus z bar. That is also it follows for the 14th theta z minus theta z bar less than or equal to theta minus theta z, which implies that the theta is a contribution of the mapping on the r power n. Hence there exist unique points of x star and then x star such that the theta z star and so on x1 star and so on x of n, xn star, y1 star and then yn star t, and then the two system of the impact of the x layer and equilibrium points. Then implies that the xi star and so on xn power t is an equilibrium points on the system number 3.7. The last numerical example we consider the time variation delays and leakage term. There are also the last system we can use it for for example the first epsilon 0.04 and then next epsilon 2 0.028 and then second theorem of theta 1 0.32057 and then theta 2 0.283. Then last and m equal to 0. Total variation 3205 less than or equal to 1. The theorem 1 and 2 and the system number 3.7 as a unique equilibrium points of the global asymptotes stability. There are the conclusions and then the references.
studied global global stability. What do you mean by global stability?
There are also mixed values.
No, I am asking what do you mean by global stability of an information? The simple definition or just casually you can explain proper definition of it.
That is, lot of elements is also collected.
What do you mean by stability of the
Then X layer and then Y layers. X layer and then Y layers. There are the equal. X layer to win the X minus X bar. Then band neural network is also equal to the stability analysis.
Here we use fractional order.
Yes, sir.
Is there any physical meaning of the fractional order of the new system?
Yes, sir.
What is that? Do you explain? I'm not able to show this.
The fractional order means the total Fij, Yj.
No, Professor is asking physical meaning.
What is the meaning of fractional order in case of Mr. Fajit?
Memory square is
what does it mean, beta? For this system,
there are the systems.
fractional order derivative that. In your system, what does it mean?
There are also AIJs.
Please see this letter. There may be some like meaning in case of any system.
Second is
I am not getting that global stability of the equilibrium. So how to distinguish local stability of the equilibrium point and global stability of the any explanation from your side? You can have it.
thanks.
One question, in your research model, you applied fuzzy technique, right?
Yes, sir.
Where you found that vagueness in the global stability? There is a vagueness in the global stability analysis, so that you can apply fuzzy model.
Yes, sir.
Then where you found the fuzziness in the global stability?
And then logics and
These are general questions. No need to go for any kind of mathematical statement.
Just explanation.
See, you cannot add such any fuzzy term to any system unless otherwise system requires some vagueness. System exhibits some vagueness, you should not apply fuzziness. What Professor is asking now. So, in what sense your model express vagueness?
That is the, you see the criteria, that is the main, that is what is the underlined framework for your research work. That you should know it first, why you are applying fuzziness. And you are applying fuzziness means somewhere impreciseness or vagueness is there. And how it is coming out, then you have to find the relation between these two.
Important one.
Yes.
So as such, just for to get some research article, you should not apply as such fuzziness.
yes, sir.
Okay. Okay. So my question is, what is your contribution in this particular paper?
In this paper, the stability analysis. There are the two layers are equalated.
No, your
contribution. See, you are yourself and your guide or authors for this particular paper, right?
Yes, sir.
What is your contribution and what is your guide's contribution?
Okay, Mr. Director, you have look on this all questions. Huh?
Yes, sir.
Okay, I wish you all the
Good evening to one and all. I am Bhuvaneshwari, National Full-Time PhD Research Scholar under the guidance of Dr. D. Ishwaramurthy, Associate Professor, SAS VAT Vellore. Today I am going to present the topic is comparative study of multifractal dimension on self-similar graph. I given the abstract, the overall the structure of the graph. Fractal theory is a popular technique is analyze non-linear system and complex graph. The purpose of this study of define fuzzy version of GFD and compare the fuzzy GFD with usual GFD for extended sapiency graph. The obtained computational of result in this paper indicate that the complexity of the graphical structure is increased with the number of iterations in terms of the cell similarity, as the values of fractal based measure are increased with the iteration for the generalized sapiency graph. The comparative study will lead us the estimate of non-linearity and analysis the cell similarity of real time the graphical network using the fuzzy based multifractal measure. Next is introduction to fractal. A fractal is rough or fragmental geometric shape that can be split into parts, each of which is at least approximately reduce the size copy of the whole, a property called the cell similarity. Fractal geometry is a concern with the property of fractal objects. Object is known as a fractal that were too irregular or complex to fit into traditional geometric setting. The fractal themselves have their own dimension. Using the two method of the first one generalized fractal dimension method is next is fuzzy generalized fractal dimension method in sapiency graph. First generalized fractal dimension method, then the generalized any fractal dimension or the generalized fractal dimension of order q in minus infinity to plus infinity for known as a probability distribution can be defined as the generalized fractal dimension is denoted by dq, limit of r tends to 0, 1 by q minus 1 log of 2, summation of I equal to 1 to n pi of q log 2r. dq means the generalized Renyi entropy method. The first method used to generalize fractal dimension used to generalize sapiency graph. The second method fuzzy generalized fractal dimension method. A fuzzy logic membership function on the set of S divided by n number of copies S1, S2, etc. could Sn. The characteristic function of mu is membership value is S2 close interval 0, 1. The fuzzy generalized fractal dimension with order 2 q in minus infinity to plus infinity. The fuzzy logic membership function reference state of graph is S is denoted by the fuzzy generalized fractal dimension is denoted by f dq, limit of r tends to 0, 1 by q minus 1 log of 2 summation of I equal to 1 to n summation of x in xi mu of x in whole power of q log 2 r. Next is generalized sapiency graph. A graph G equal to V comma E, V is a vertex set and E is a edge set. Is defined the Tth generalized sapiency graph is denoted by S into G comma T of the graph. Vertex set V power T is the edge set is denoted by U comma V if there exists of I in 1 comma 2. This condition will satisfy the generalized of the sapiency graph. First condition, J is less than I, Uj equal to Vj. Second condition, Uy comma Vi in edge set of V, Uy not equal to Vi. Third condition, J is greater I, Uj equal to Vi, Vj equal to Ui. The generalized sapiency graph is applied to the two method. First method generalized fractal dimension method. Second one is a fuzzy generalized fractal dimension method is applied to the generalized sapiency graph. This in figure of the generalized sapiency graph. First iteration 1, second figure is iteration 2, third figure iteration 3. To apply the concept of the first membership values and close interval 0, 1, close interval 0, 1 is assigned the vertices. The first is the scaling factor of 1 is iteration 1. Second is the scaling factor of 1 by 3 is assigned the second iteration of generalized sapiency graph. Third iteration 3, to assign the values of the scaling factor of 1 by 9 is 0.11. To assign the membership values of closed interval 0, 1. Result and discussion is a table 1. Next I compute the values of GFD and fuzzy GFD in generalized sapiency graph in MATLAB software to calculate the first one. Generalized fractal dimension is a Q in assign the values of Q is minus infinity to plus infinity. To assign the values of 2 to 10 is a even number. Even numbers is iteration wise increases. Q values increases, the complexity values also increases. Second one is calculate the fuzzy. Second one is calculate the generalized sapiency graph to compute of the fuzzy generalized fractal dimension to the MATLAB compute of MATLAB software. Q is assign the values of Q is 2 to 10 is a even number. First one is iteration 1, iteration 2, iteration 3. Iteration wise is a increases. Q values increases, the complexity values also increases. To compare the GFD and the fuzzy GFD, the fuzzy GFD is a increase, is the highest values. Is a fuzzy GFD is a best. Using two methods is a compare the GFD or fuzzy GFD is a fuzzy GFD. Fuzzy GFD is the best method. Conclusion: in this study we are considering cell similar or generalized sapiency graph fractal to measure the complexity by means of computation and comparing generalized fractal dimensions with fuzzy generalized fractal dimensions. These are my references. Thank you, sir.
Nice presentation. You are considering some complex, right? Complex. What do you mean by complex? Not required to show this slide. Just you explain, considering that no idea from my side. Just explain, not required properly.
Formula. What is R? What is R?
What is the scaling factor?
Scaling factor.
Scaling factor. What is its range? Range value you mean minus infinity?
No, that is for Q.
Raw.
What is Q actually? Order Q belongs to minus infinity to infinity for the known probability distribution. What happens when R goes to 0?
log 0. What will be log 0? Log 2 plus 2.
You are applying the limit r tends to 0, and in the denominator log r is sitting.
R means small r means scaling factor.
Okay. You go to next formula. Here, where is fuzziness? Okay, I will help you. What is the function mu?
Mu means membership values.
Membership of what?
Membership values of other verticals.
Okay, you need to read that.
Okay, you go to the slide number 10. I think you have shown some tables, right? Okay, what these numerical values represent in graph?
Have you taken any graphical representations or yes?
What do you mean by these numerical values with the graph?
See, what is Q?
Q values assigned to minus infinity to plus infinity.
Okay, you have assigned 2, right? This is the fuzzy generalized fractal dimension of what?
Okay, you calculate something 13.368. How you will explain this value to the because you calculate this values for some graph only, right? So you should relate these values to the graph. How these are related? So how you relate these values with the graph, and what you would like to explain about the graph? Okay, you please check all these points later. Okay. I wish you all the best.
Pointer is here. First one is pointer.
Good evening, one and all present here. I am very happy to introduce myself in front of you. Myself, Sasikala, a research scholar, Department of Mathematics, School of Advanced Sciences, Velu, PIT Velu. So I am doing my research under the guidance of Dr. M. Prakash, Department of Mathematics, VIT Velu. So my presentation title is Adaptive Control Based Synchronization of Stochastic Neural Networks with Mixed Time Delays. Before I am going to the presentation, I want to ask one question. If you hear the word, if you hear a word synchronize, did you get any points? That means what is mean by synchronize? Can you tell me, sir?
You are asking us if we don't know anything like that, you try to explain.
No, sir. So, why I am asking that is, whenever I am starting my presentation, I want to attract the participants. So only I am asking the questions.
No.
So this is my outline of my presentation. I start up with my objectives. So my main objective is I want to synchronize my neural network model along with the mixed delays and adaptive controls. So how here I use the methodology is I defining some Libno functions using some numerical simulations for my neural networks to prove the effectiveness of theoretical frameworks. Next, let us see my math. Before that, we should know what is meant by modeling. So modeling is the mimic nature creature of real life situations. It is a mathematical language. Modeling is a mathematical language. It is represented in the form of equations, graphs, or some relations. So next, let us hear the basic model of my neural network model. So here I am considered a non-linear neural network model. So x dot of t equal to a into x of t plus b into g of x of t plus g into x of t minus tau of t. So I want to explain this. First, this is my a is my induction neuron coefficient. So here I define x dot of t is x1, x2 up to xn. Here I considered n number of neurons with their respective values. That is, minus A is inversion neuron coefficients. Here B is my weight matrix and G is my activation functions. B and C I considered as a weight matrix and G and G is considered as activation function. Here the general model having some delays. Without delay also we have a neural network model. So whenever I am taking a delay, we have to concentrate on tau of t. It should satisfy this condition, then only we can proceed our system. That is, tau dot of t should be less than or equal to gamma. Gamma should be belongs to R. So my proposed model is stochastic neural network. So what is the difference between the previous slide and this slide is, so I want to introduce stochastic term in my model, and I also used mixed delays. So what is meant by mixed delays means, here I considered one delay, that is tau of t, that is time varying delay, and I have to introduce distributed delays. I introduced two delays and then I introduced the stochastic disturbance in my model. So here F denotes the matrix of adapted dimensions and the stochastic patterns are always represented as W of t. What is Brownian motion is, the Brownian motion will occur during the stochastic process. And then D is, it is the distributed delay constant weight matrix. D1 of t and D of t is the time varying differentiable function. Next, this is my master system. Why I call this as a master system means, this is my base model. So for an example, I am here, if I want to, for an example, if you are taking any robot, I am not disturbing myself, but I frame one model like me and I want to give the control to that model if the model should be behave whatever I want to do. So this is called master system. Based on the master system, I want to define, before that I want to give some explanation about time varying delays. So time varying delays is a delay whose value changes over time. Depending on the time, it will be changes. And then for an example, if I want to send a message to my 5 friends, they are receiving the message, but there should be changes in their time. Why? Because there should be a network traffic. For an example, if I send a message at 5 o'clock, but somebody receive 5:1, somebody receive 5:2. This is happen because of time delays between the receiver and sender. And then distributed delay. What is distributed delay is, the delay should be spread out over the system rather than be concentrated at a singular point. So different from time varying delay, distributed delay is distribute the delays over the system. So that is the advantage when comparing to time varying delay. For an example, if I want to send a control signal to the physical actuator, can vary depending on the length of wire. For an example, if I give a short wire to the two actuator and the controller, what will be happen? The power supply will be different. So that is the distributed delay. Example for distributed delay. So next, let us see the mathematical modeling for my master system. So what is the difference between these two systems is, master system as it is, based on the master system, I want to construct a control in the system. So that is U of t is my control. So here I am taking one control, that is the adaptive control. So what is meant by adaptive control? So adaptive control is, it automatically changes the parameters. For an example, this, if I am giving adaptive control for my system, what will be happen means, depend upon the system behavior, it will automatically changing my parameters. Without man help, it can be automatically changed. So here the main goal is, it will see the desired performance of the stability of the system and it will be automatically changed. So here I am taking U of t equal to k into E of t, that t should be within the limit tk to tk plus 1. I am taking like that. So here adaptive control, whenever we are defining adaptive control, I have to give some law for the adaptive control. So here I am designing a adaptive law like k dot equal to eta of E squared of t, where eta represents as arbitrary positive constant. Next, let us see this is adaptive control structure. So when you see this, here we are having two loops. How means, first if it is go to the controller, first it is go to the controller. After that, before going to the system, you can consider the system is my system, that is neural network model. So if I am a controller, it goes to the parameter update. If there is any parameter update, So adaptive control, what will we do is, it will see the how many parameters are updated, randomly changing. So it will pick up the randomly changing parameters, and then that should be controlled by the controller. After that, control should be passed through the system. Finally, we reach the destination. Suppose in another we can do that. First, I am starting from the set point. After that, directly it go to the parameter update, and then the control parameters it will control, and it will go to the system, and it will be output. So this is a error system. Okay. So I will tell and move, sir. So error system means if I am subtracting master system with the slave system, I will get the error system. So you can see this. So theorem, this is the main theorem for my research. That is, if I am taking two P and Q be the some positive definite matrix. So what is positive definite matrix means? It should be, all the eigenvalues should be positive. And then it is my LMI. If I think psi of 1i should be less than 0 means, I can say that the system is globally stochastically stable. So this is my Libno-Krotsky function. There is a condition for taking a Libno-Krotsky function. First one is quadratic form, this one is for adaptive control, and this one is for delays. Third Libno function. And then here we have to find the derivative using Ito's formula. After getting the derivatives, I want to sum up it. Finally, I conclude this. Theta consists of t into e1 of I into theta of t. So theta of t, that means my collection term using LMI tools. So if I am taking the derivative of this, that means derivative of this, we are getting exponential. If I am taking exponential of the stochastic term, it will be 0. So I am not taking. And then by using Daykin formula, I can get the solution as this. If I am taking, that is, if I am and my Libno function is continuous, finally I can conclude that it is globally asymptotically stable. So this is the numerical simulation part. Here I consider 2 neurons. I am not considered any n neurons. Just I am taking 2 neurons for my verification. So here I will provide the coefficients. So that should be for giving coefficient matrix. So here you can see C1 and C2 are diagonal matrix, and then A should be this value and A2 B1. Based on the system we want to define the matrix. And then this is my state response of the first neuron, because here I am taking 2 neurons. The first neuron X1, Y1, and then this is for second neuron. Finally I synchronize my 2 neuron model. So finally I achieve the global asymptotic stable of my system. So what is my contribution of this paper is, till now no one can do a research in synchronization of stochastic neural networks with mixed delays and adaptive control. So here I done it. This is my references. Thank you for your attention. Sir, because in previous literature survey I had done it, they are taking only one delay, tau of t. Because if we are taking 2 delays, what will be happen? There is a tremendous challenges for us, because it is distributed, one is distributed, one is continuous. So I will face lot of things here and getting the synchronization. So only I will try this.
Are you getting any interesting result due to this?
Sir?
Any interesting result due to this?
Yes sir, I will synchronize the system. If with the mixed delay, what will be happen for my neural network model? I will show it, sir.
So, what is the difference between previous one and your one?
Sir, previous one they are generally taking time varying delay and then synchronize the neural network model. But here I can do it for mixed delay with adaptive control. Because adaptive control, if you are taking, means they are automatically randomly changing their parameters. So we can't able to control when we, here we are having lot of control, sample data control. Sample data control is a constant. Whenever we are giving the terms, we are giving the control for the system, there is no changes in their parameter automatically. But in adaptive control, we have the advanced future. Based on the system performance, it is automatically updated. Yes, sir.
Go to the beginning.
Yes, sir.
be your guide name?
Yes, sir. So what I feel is.
It is research work under him only, na?
Yes, sir. Yes, sir.
Then you should include.
Okay, sir. Surely, sir.
But she mentioned. She mentioned.
What I feel is, well, suppose whenever we are giving in slide, it should be visible to everyone. So if all the content, if I am given, it is.
It is visible. Okay. It should be there.
Yes, sir. Surely.
So just you can like date is there, na?
Yes,
In
sir.
between you can.
Yes, sir. Surely.
Many
Next
places
presentation
there.
onwards, I will do.
This is it. You have seen other slides, other students, they have included or not?
Yes, sir. Yes, sir.
Like-
Surely, sir.
Okay.
So, where is the stochasticness? Go to your model and then take it.
Yes, sir. This is my model f of x of t into dw of t. So this is up to dt is deterministic term, deterministic model. This is the stochastic term.
F x of t
Into
dw.
d. Yes, sir. Whenever we are defining stochastic term, there should be some matrix involved.
W of t is that is Brownian motion.
Yes, sir. Whenever we are speaking about the stochastic predominance in
Okay, go to example where you have given this particular part.
numerical simulation we are asking.
Yes, yes.
Okay, go to the previous slide. I have one question. No, first slide. That model you have taken. Yes, wait.
Yes, sir.
Previous slide you go.
So this is general neural model.
Okay. My question is here only.
Okay.
X of t equal to minus a into x of t, b into g of x of t, something.
Yes, sir.
This is already existing model.
This is general neural network model.
General neural network, you need to give reference, no?
Without the basic of the model, I can't able to extend of
Yes,
the model.
but
Sir, so only I am.
you need to give reference. That's what, right?
Citation can add.
You can add something directly how taken,
Yes, sir.
and before taking you should explain what it represents physically. Then you take the model and explain. That is correct. Directly you are taking equation. So
Why?
better.
Because consistence of time only.
Okay, no problem. Just we are giving suggestion. We are not saying it is wrong.
Yes, sir.
Because research means what it is, step to step.
If
and
you
then-
give a permission, I can explain this.
No, you just listen. You see, research means what it is, step day to day, you have to improve yourself. That is the research model. And this is general non-linear model. This is fixed, sir, everywhere.
Sir,
We cannot
here
have-
only one change is there, sir. Here I introduce delay. Without delay, we have a neural network.
That is
Log
last
of
step.
t. Yes, sir.
Okay, first two terms are fixed.
Yes, sir. Yes, sir. Because in neural network model, we have a 3 layers. Input layer, hidden layer, output layer. In input layer, I want to give the input. That is x of t I want to give. Okay, sir. So here, why I give a minus here is the signals are changing from one neuron to another. So I am using minus a. After in the first stage, after that it goes to hidden layer. In hidden layer, what is the process is weight, activation function and bias is there.
Okay, my question what it is now, can you confirm it, assure that this model is the best general model?
No, sir, I can't able to do this because I am doing in some other model in neural network.
That's what I'm saying. Why don't you have your model?
Yes, sir, I am
You
trying.
know what's the name of this particular model?
Sir, this is general nonlinear.
There is a name for this. Who developed this model, you know?
Okay, because it is the best model for your research, you should know it. You should find it, okay?
It's a Hebbian model. Okay, it's a Hebbian neural network model. Only in Hebbian neural network model, one input layer, one hidden layer and one output layer. Only Hebbian neural network model is having 3 layers. But it is not necessary that only one hidden layer should be there. Even you can have many hidden layers in between, right? Only in Hebbian neural network model, that is this particular thing, Hebbian neural network model. Okay, this is a Hebbian non-linear neural network model. Okay, you should know this. Okay, and not here, but at least whenever you are writing a thesis, you should name who has given this. If you go back and see the literature, this particular model was given by Professor Emia. Okay.
In future work, you better to design your own model in this domain.
Because I am working in some other models also, I want to combine.
Okay, just compare. As far as there are many hidden model layers are there.
I also try to do
I think
in
those
AI.
are the characters of the neurons, sir. That's what. So you better to take some other new model and design it and verify it whether it is suitable or not to get the better results.